Thank you, everyone, for coming. It's always really nice to come to London. Thank you, British people, for making me feel like I'm at home every time I come. My name is Ricardo Cruz. I'm from Xojo. And today we are going to talk about microservices. Their benefits, their few benefits, their lot of challenges, and some of the best practices and recommendations that I can give you. During this session, we will be also seeing a few common patterns that we will be sharing and we will be seeing while using Xojo. But microservices are really a generic topic, so we won't be seeing any Xojo code at all in this session. But you can apply it using Xojo. But before we get there, what's a microservice anyway? And I got the question before we were starting. They are really small applications or small tools that has just a single responsibility, like in Unix. You have a lot of little command line commands that you can glue together to make your applications in a way that it works pretty well, because every specialized tool it only has that responsibility, and yeah, it's going to do it pretty well. The difference between a microservice and those tools is they must be able to communicate using TCP/IP, normally with HTTP, exposing an API. They should be really small to fit in your head. If you are thinking about a microservice, if we compare this to Xojo itself, I don't know every single Xojo part or every single module. But if we were working with microservices in a microservice style application, you should know everything about that microservice. If you are in charge of that microservice, you will know everything. And every member of the team will know everything as well. But it should be big enough to make sense, because they have some overhead. So you cannot make a microservice for every single piece of the application. So you have to find the balance. But if you know everything about the microservices, you will probably be okay. If we compare it to a monolith, the typical, Xojo web application, for example, where you have everything inside, you have the accounts module, payments, notifications system, like, for example, sending transactional emails for the user registration and all this. You will have everything in one application, in one compiled code, for example. Microservices instead, some of the pieces are going to be in their single code base. They will have their own repository, and if you want to scale just one of the module, you can just replicate the instance of that microservice in just the same server or a cluster of services. If you want to replicate the same monolith, you will probably be wasting some resources when you want to just scale the notification system in this case. So some of the benefits. I didn't list everything about microservices, but yeah, probably the best ones. You can pick any language, like, for example, Xojo, whenever you are doing a microservice. Before joining Xojo, this was my way to introduce Xojo into the company, because we had a really big product, and we were able to introduce Xojo in just a little microservice. So for example, I heard one of the users that wasn't able to use Xojo in their company. So this could be a way to make your favorite language inside your company. You will also have independent teams. So you can have a group of 3 or 4 people in charge only of that microservice, and that microservice can have their own policies, for example, the security policies, their error rate quota, licenses, and everything. For example, if you need to pass a PCI compliance for processing card payments, that microservices is going to have to pass that compliance, but not the whole application, maybe. As everything is split in different processes, you will probably have less code conflicts, because you are not going to be sharing a code base with, I don't know, hundreds of users. So conflicts in a microservice architecture is going to be easier in that way. Because they are really small, they are disposable. You can just rewrite that microservice maybe in a week, and you can have a first version ready in a week or a couple of weeks. So if you need to rewrite something that it has 10 years of lifespan, maybe you will be able to consider to rewrite that piece if it's small enough. If you are thinking about rewriting a whole monolith that has 10 years of life, maybe you will keep postponing and postponing. But with microservices, well, you can do it. For example, if you want to migrate Web 1 to Web 2, an application of Web 1 into the new web framework, you can start doing it part by part instead of migrating the whole monolith. But if you want to know more about migration, an application from Web 1 to Web 2, we will have a talk on Friday, I think. So you can assist. Another thing that microservices enables is you can deploy your code very frequently. And when I say very frequently, I can say Netflix, for example, they send their code to live 100 of times per day. So they are really common. If you are watching Netflix, or you are using Uber or any other application, you are shopping on Amazon, you are probably hitting a microservice application composed by, I don't know, depending on the size of the company, could be a lot of components working together to make it really easier to develop, but as we will see, a bit complex to maintain. In theory, it's easier to scale horizontally an application based on microservices. If you think about a Xojo web application, for example, the normal way to make it scale, it will be vertical. So you will be buying more RAM and more CPU, and you will be fine. And in normal cases, that will be fine, and you won't need to split the monolith in several microservices to keep growing. But yeah, in theory, at least with microservices, it will be really easy. They are small. By definition, they will be limited. And for example, you shouldn't be able to write anything into the hard drive. So that will make it easier to move an instance of your application from one server to another. So yeah. When I say it's easier, in theory, it's because maybe it's easier to start a new project using microservices, but you will have to deploy them, and you will have to start sending requests and routing all this communication between the services, and it's really hard, okay? But if you have a system administration team, they are really used to it, and they will do it. Sometimes it's easier to defend if you prepare a microservice application that is exposing only part of the API. You will be able to defend only that part very hard, and the other parts of the application, like, for example, this email validation service that we have in the right bottom corner, it won't receive direct traffic from the internet. So you will still have to validate the input, but it won't receive real traffic from internet. So in theory, it will be easier to defend because it has less attack surface. Another really important feature is that you will be able to support more fault tolerance. For example, if the login service goes down because in that specific server it runs out of hard drive, that microservice can crash, but the application in general can still keep working. The email validation service could be storing locally in a queue everything that it will be sending to the login service. So whenever it comes back again, it can send all the traffic again to the login service. Your application will continue working even if some of the internal microservices are down. Yeah, they are so fun to work with because you don't have any rule, you don't have any technical debt, you don't have anything against you. You start always a greenfield project. Everything is new, and you can pick any language and all this. The challenge is, that's another thing. I actually had to remove a lot of slides because I was getting depressed, but that doesn't mean that they are bad at all. In some cases, they are the only option, and they are pretty common for a reason. So don't get scared because of these challenges. They are all solvable, so don't worry. First of all, you can have a chain of errors that can be start to replicate between all of the microservices. And if one of them starts corrupting the database, probably you won't be able to stop it. And you will have to fix not only one database, but in this case, 4 databases. So that can happen. It happens. Also, as you will start receiving a lot of communication between them, it will be a little bit harder to detect a bug, or you know that there is a bug, but it's not that easy as opening Xojo web and put a breakpoint and everything is fun and flowers. You will have to be dealing with a lot of login files, try to see where the bug is coming from. Setting up this could be really difficult. You will have to be configuring a lot of services. If you don't like to deploy Xojo Web, for example, and you are paying for a Xojo Cloud service, then imagine how daunting could be to create a cluster of servers to support of this microservice architecture. Could be harder. For example, if you want to maintain a configuration or you want to change any value in the configuration, you will have to do it in a lot of places, not in just your single project. Sometimes, if you don't architecture this application very well, you will end up building a new feature, and in order to deploy that feature, you will have to touch like 4 or 5 services. And that's, that could be hard, and it will probably slow your time to deploy. Degraded performance, because you maybe are waiting for other services to give you a response. So if you are doing a chain of calls in order to receive a response, you will be probably adding up a lot of request timing. So yeah, probably you will be trading off some scalability and reliability for degraded performance. It's not that bad. This is just an example. And yeah, also data inconsistency. In a Xojo web project, for example, you are just calling methods from another class or another module. That's really easy. But in a microservice architecture, you will have to be waiting those replies to come to your server again. And they can come in a different order. And that makes this way of working a little bit harder than the usual way to work. It's also complex to deploy. You are not only deploying one service, you are not pressing on the deploy button of Xojo Web. You will have to be deploying a lot of individual places in different servers. So yeah, you will actually probably need a system administration team to orchestrate all this. So yeah, monoliths are not that bad. But that doesn't mean that microservices are a bad idea. They are used everywhere. They have, I mean, the benefits that they bring in the scalability and reliability. Sometimes it's just what it is, and you will have to adopt it. In order to reduce some of these issues, there are some patterns that we can start using, and you don't really need to follow all of them. They are there, like, I don't know, test-driven development. If you like it, you can use it. And these patterns are there because they really help. But if you don't want to follow them, that's OK. The first of all is the edge server, or edge service, or API gateway. Everything means more or less the same. You will be exposing only one server to the internet, and it will be in charge of receiving all the traffic from the internet. And internally, the microservices will be doing all these calls, but they don't even need to use HTTP. They can be just connecting using a socket, for example. The next one is the service mesh, which is a fancy word for a proxy. They will be in charge of routing all this communication between microservices. You put a sidecar next to your service, and instead of trying to look where is the microservice that you are trying to connect, or even if there are a lot of instances of that microservice, you will be able to just call to your proxy, and it will be in charge of everything. It will look for the load balancing, the routing, and also it will be logging probably all these, sorry, all this communication. So you can see also in a web panel all the traffic that is happening in real time, or you can see if one of the microservices are still used or not. Reactive services, which is one way of doing this, is just asynchronous communication between the services. You will be sending messages without waiting for a response at all. The receiver, it will receive that request. It will store it in a local queue. And whenever it can, it will be sending the response to the caller eventually. Sorry. And the core idea is just to not block the process at any time. The other way of doing the same is using message brokers, which is pretty used everywhere in the microservice architecture applications. We will be sending events like we do normally in Xojo. This button has been pressed, and this event has just happened. So every other service can subscribe to all these events, and they can all react to those events in real time. Another pattern, this makes things really easier, is to have, sorry, just to have only one service that is in charge of all the configuration. For example, if you want to swap a payment password, you will have to change it only in one place, and you won't have to change the code of your application. You won't have to rebuild it. You won't have to redeploy it. You just change one config line in one place, and it will be replicated everywhere, just like a key value store. The same for the logs. Instead of logging everything in every single microservice, you will store them everything in just one place. Like, for example, if you are using Kubernetes and all this, you will be able to receive all these logs in one single place. Now, some recommendations that are coming from horror stories. You will be better if you start with a monolith, for example, a Xojo web application. And eventually, if your application grows and grows and you find that you cannot keep growing it vertically, then you will extract just the bottleneck, and you will create a microservice from that. And that microservice, you can start creating multiple instances of only that instance. Yeah, we will see tomorrow how we can start doing this kind of things. The good thing about creating a microservice from a monolith is that you may find a software that you can sell as a side effect of that. For example, I've seen this happening in a company that was sending a lot of messages. So they had this bottleneck. So they've extracted that notifications module into a whole service, and they've started to sell a transactional email service. So you want to do versioning to your APIs. You can start with V1. So as soon as you have your API stable, you will freeze it. You won't touch it. If you need to break the contract, you will just duplicate it and start working on that new version. And you will keep working on the previous version until you know that nobody else is using that previous version. And you can know it if you are following the other pattern, the service mesh. You will have all the metrics. This is what I was talking about, not storing anything on your instances, because you will be probably using containers, like, for example, Docker. They are also, they can be removed at any time, and all the data will be lost. So you won't be storing any data inside that microservice. Instead, you will use a managed database, like, for example, Postgre in Xojo Cloud, or another service to store the, I don't know, the user profile picture or that kind of things. And yeah, automate everything. You will have to be automating building. You will have to be automating tests, security checks, deployments, everything that you can automate it, because otherwise you will be suffering a lot. You will have a lot of moving pieces that you need to coordinate. So yeah, probably you will need or a team of people that will be in charge of this, or for example, a person like Travis that will be automating everything to make everything smooth. With Xojo, sorry, we have a few options. We have the server socket, for example, if you want to create a TCP socket that communicates internally with another microservices. And you can use a console or desktop target, but normally what you will be wanting to do is use Xojo Web. Using the application handle URL event, you will be able to receive the API request and give the response from there. The good thing about Xojo Web, which is not happening more frequently in other languages, is you can prepare a really nice dashboard in a really easy way. Yeah, you will be using containers all the time. You will be using Docker normally, and you will be packing everything inside a container, and you will give it to the team of the sysadmin team, and they will be take care of it, and they will deploy it using Kubernetes or Nomad. They are orchestrators that will be handling all these challenges that we've been seeing. If you want a really easy way to deploy them, you can use Nomad, or if you want to use a more complex tool, but it's covering a lot of those patterns, you will be using Kubernetes. Questions? Or any horror story or any success story? Yeah.
I don't know anything, but about Docker, it's an application, Docker?
Yeah, Docker is a way of put everything, like, for example, the binary that you will be generating using Xojo and all of the resources that it needs. You will be packaging, like, I don't know, you can imagine it like a zip file, but it's a really common way to run that package into a cluster.
Okay.
Yeah.
You said with the web services the dashboard was easy. What did you mean by that? How did you think a dashboard would be?
Yeah, the question is, what do I mean by building a dashboard is easier? Yeah, I mean, when you create a microservice in any other language, you probably won't even care about building a dashboard, because you will have to be dealing with all the HTML. You will have to be dealing with talking with the API to have all this data and displaying the data. I don't know. I feel it personally that it's really easy with Xojo Web to create a microservice because, I don't know, you can just drag and drop a chart control and you can show the
So are you thinking then that you've got a web service, but you have a page which shows you what's going on that instance of it? Is that what you thought?
What I mean is your microservice, like for example the notification system, you will be able to expose all the metrics really easily in a dashboard using Xojo Web. Yeah. More questions?
Do you have an example in the examples?
I think we have an example, but tomorrow we will be doing a whole session creating a kind of intranet, but it could be the skeleton of a microservice.
I created a web app that had to search database with millions of records. And so if somebody did a big long search or something, it slowed everybody else on the web down. I was thinking maybe I should be using workers or something like that. Would you, I know workers aren't available for the web yet, would you use a worker for the web if things, or would you use Docker, or would you use other microservices?
Yeah, well, in order to scale that application, I think that's more or less a question. You could be, at the moment, you can create more instances of that Xojo Web in that server, but yeah, probably you could be extracting that bottleneck into a microservice, and yeah, you could be replicating only that microservice.
The problem I have, if I use Docker and, say, run 10 instances, if two people happen to be on the one instance and one person slows it down, even though it's not everybody, still that second person is slowed down because of the other user. So...
but in the same server, or?
Yeah. So, like, how many Dockers am I going to create so that it's only ever really got one person on every Docker instance?
Yeah, you can build any number of Docker containers, and they are not required at all, but if you want to start doing microservices, you will end up there. But
so
yeah.
Say that to that point, that's where having a dashboard and looking at the statistics really helps a lot, that you can then make sort of an informed decision about how much do I need to accommodate the load. And so what you might do would be, in that case, use something like Nginx as a load balancer. But then what you can do, again, if in certain environments, you'd be able to look at the load and how Nginx is distributing things and spin up new instances or close them down sort of as you go. Now that's getting considerably more elaborate, and you need a pretty large load to doing that, but it's possible.
In the end, I created a console app that ran in the background of the web, and you would pass the job off to the console app. It would do the work and then tell you when it was finished.
Yeah, and that's one of the ways of building a microservice, just using a console. But if you want to refer it as a microservice, you will have to be communicating using TCP by HTTP or whatever. You won't be calling command line control. I mean, you can do it, but it's not the web. It could be a kind of microservice, but it's not the. And running all these applications using Docker, which was more or less the question you had, it's a standard way of running any kind of process in any language. Like with Xojo, it's really easy because it's just a binary. But if you are using another language in your architecture, it will be always the same. You will just start the container, and it will be always working the same. And the system administration team, if they don't know Xojo, they will be able to run it anyway because it's just another container, and they don't care what it's inside.
Okay, so you mean with Docker, I can have different applications microservices with different languages,
Yeah.
but it
Yeah.
doesn't care, so it just makes their own.
Yeah, you don't care what is inside. It's just a standard way of running processes.
Okay.
If you think of Docker as being kind of like sort of a lightweight VM type of.
Yeah, it's like virtual machine, but without the overhead of having a virtual machine, because it's not going to be using any memory that it won't use. You don't have to reserve that much memory because it's not running any other process, only your process.
Okay.
Is it possible to manage the cores the CPU cores to use?
Sorry,
Is it possible to manage which CPU core is used for what?
is it possible to manage?
Which of the CPU cores
Yeah.
are used?
Yes, it's possible to manage which core or which CPU is going to use. Maybe using containers, you can tell the orchestrator to use only one CPU or 4, or use 20 servers in a cluster with the instances. So it will be replicating one process per CPU. So yeah, you can do it with the orchestrator with Kubernetes or Nomad. Yeah.
Just also to one of your other points on the automation.
Yeah.
That's really, really handy. I had an instance last year where basically after developing sort of some fairly complex microservices,
Yeah.
we were talking back and forth amongst Amazon services. We got it really locked down in terms of the Amazon security, and then when we went to go and move things, nothing.
Yeah.
Amazon security really, really does work, and nothing would
Yeah.
talk to anything else. It was quite difficult to work out where were things breaking down because there were so many moving parts.
Yeah.
And so automation really, that's when I started using automation actually after that.
Yeah. If you want to start with microservices, you probably start automating the server creation, I don't know, everything, the building, security, everything. Yeah.
Setting up, configuring the security groups actually.
Yeah. There are a lot of tools, and there is the cloud landscape is so huge that it won't fit here in the whole room, probably. There are tools for everything, for configuring Amazon Web Services, for I don't know, everything you can think. There's a tool for that, which is really nice, but you will have to be learning a lot. More questions? Okay. As Paul said, we will be around if you have any question about microservices or any other thing about Xojo Web. I will be around, so just let me know. Thank you very much.